Concept which we are studying is we want to find out the molecular weight of a gas, or we can calculate molecular weight of a mixture of gases from ideal gas equation. So what is meant by ideal gas equation? PV is equal to N0. This is called ideal gas equation, no? So I can write down PV is equals to N can be written as total mass divided by molecular weight, no? Or molar mass multiplied by R into T. Can I write like this? We know how to calculate number of moles, no? Total given mass divided by molecular mass. Okay. So total volume divided by volume of 1 mole of gas at STP. Clear, no? Or you can calculate total number of molecules divided by Avogadro number of molecules. So these are the different methods of calculating number of moles. So therefore, N I am writing in terms of total mass of the gas divided by molecular mass. Clear, no? So therefore, M can be written as small m divided by PV multiplied by R into T. I can write like this also, no? So therefore, if you take the ratio of mass and volume, then it is called density, no? Density is called mass by volume, no? So therefore, what I can write? Molecular mass is equals to density of the gas divided by pressure of the gas multiplied by R into T. So I can write like this also. Clear, no? So this is the equation to calculate molecular weight of a gas, or molar mass of a gas, or molecular mass of a gas. Clear, no? So density divided by pressure multiplied by R into T. This is one equation. Understood? Now we will write some cases, ma. Case number 1 is if there is single gas present in the container. So what is meant by single gas present? There is only one gas present in the total container. Then what is M? M is molecular mass of the gas. Clear, no? So for single gas only. Okay. Then what is meant by density? Density of the same gas. Density of single gas. Clear, no? Similarly, if I take pressure, then this is the pressure of single gas. That's all, no? So instead of taking single gas, if I take a mixture of gases, mixture of gases. What is meant by mixture of gases, ma? So some 2 gases, 3 gases, 4 gases are present in the same container. Are you able to understand? So more than one gas also can be present, no, ma? So in that condition, what will be M here? M will be the molecular weight for mixture of gases. Okay. So molecular weight for what? For mixture of gases. Clear, no? Similarly, now what is meant by D here? D means what? Density of total mixture of gases. Okay. Similarly, what is meant by P? P is the total pressure of all the gases. Total pressure of all gases. Are you able to understand? Same equations we can write in different methods. That's it. Okay. So M is equals to D by P multiplied by RT. This you can use for single gas also, or for a mixture of gases also. If you are taking a mixture, for total mixture there will be some molecular weight, no? That is molecular weight of the mixture. D is the density of total mixture of gases. Clear, no? And P is the pressure exerted by all the gases. Each gas will give individual pressures, ma. Okay. So total pressure is the sum of all pressures, which is called as Dalton'S law of partial pressures. Okay. Now see, ma, we will write one very important case here for mixture of gases. For mixture of gases. So consider there are 3 gases, ma. So consider this is gas A. Next one is gas B. And the third one is gas C. And total values here we will write down. Okay. Gas A, gas B, gas C, and total value. Clear, no, ma? So all of them, they are present in a single container, ma. Gas A, for example, hydrogen gas, helium gas, oxygen gas, all of them, they are present in the same container. Okay. Then can you say gas A will occupy how much volume? Total volume of the container is V. Total volume of the container is V. Then first gas will occupy how much volume? Can you say? It will occupy total volume. That's all, no? Already we studied, no? What is the property of gas? ఆశిష్ విద్యార్థి మన లోకంలోనే ఉన్నావు కదా. మన లోకంలో ఉన్నావు కదా, పెళ్లి గురించి ఆలోచిస్తున్నాము అని లేదు కదా. ఓకే ఓకేమ్మా. చిన్నప్పుడు మా అమ్మ అడిగేది అనమాట, ఒరే పెళ్ళి ఎప్పుడు చేసుకుంటాడు, 13 ఏళ్ళు వస్తానే చేసేమా నాకు పెళ్ళి అనేవాడిని నేను. అట్లా ఆశీష్ కూడా తొందరపడతాడేమో అని. ఓకేమ్మా. సో గ్యాస్ ఏ, it will occupy total volume of the container. Whatever may be the possible volume, gas will occupy all the possible volume. Clear? So if volume of the container is A, then gas A will occupy all the volume. Similarly, gas B also will occupy all the volume. Gas C also will occupy all the volume. Total volume is also V only. Clear, no? And temperature of first gas, if it is T, then what is the temperature of second gas? T only. Temperature of third gas, T only. Temperature of total mixture also T only. That's all. No? If you mix two gases, if initial temperatures are different, but after mixing final temperature will be same. So temperatures also will remain same. Number of moles of first gas, I can call it as Na. Number of moles of second gas, that may be different, Nb. Number of moles means number of particles of gas. Clear, no? And what about gas C? It also may be different. Now what is the total number of moles? Na plus Nb plus Nc. That's all, no? 10 molecules of oxygen, 10 molecules of hydrogen, 10 molecules of helium, they are present. So total how many molecules? 30 molecules are present. Clear, no? So therefore I can say, so Na plus Nb plus Nc. This is the total number of moles present in that container. Understood, no? Similarly, if I want to write about pressure exerted by first gas is Pa. Okay? Pressure exerted by second gas is Pb. Pressure exerted by third gas is Pc. Then what is the total sum of pressures exerted in the container by all the gases? So Pa plus Pb plus Pc. So Pa plus Pb plus Pc. So this point you should always remember. Are you able to understand? So students make mistakes in understanding this concept also. So if N1 moles of gas is present, it is not that it occupies only some volume of the container. It occupies total volume of the container. Understood, Nama? So volume is occupied equally by all the gases. Temperatures will be same after mixing. Before mixing, it is a different condition. But after mixing, every gas will have same temperature. Number of moles may be different. And therefore, pressures also may be different. Are you able to understand, Ma? So this is one point. Okay? Understood, Nama? So therefore, what is the formula I can write for mixture of gases? Okay. For mixture of gases, I can write down, to calculate molecular weight of a mixture, I will write M mixture is equals to D by P multiplied by R into T. Okay, ma? So D means the density of the mixture, pressure means total pressure. So I can write like this. Understood, no? Okay, ma? Similarly, we have one more formula to calculate mixture of gases, ma. What is that? Let us see. Total mixture of the density. That either he may give or he may ask us to calculate also, depending on the question. This is the formula. Clear, no? So another equation to calculate density of a mixture. Okay, ma? So there is one more formula whose derivation I am not writing, just formula I am writing. So molecular mass of total mixture of gases, I can write it is m1 x1 plus m2 x2 plus dash 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 divided by x1 plus x2 plus dash dash dash. So any number of gases may be present, 2 gases, 3 gases, 4 gases, anything can be present. Are you able to understand? Now what is meant by m1 m2 here, ma? m1 and m2 means what? m1 is the molecular mass of first gas, m2 is the molecular mass of second gas, like this. Understood, no? So then what is x here? X can be number of moles also. Okay, ma? Mole fraction also, mass percentage also, or just you can call mass also. Are you able to understand, ma? So in the place of x, you can write anything. If value is given in number of moles, you can substitute number of moles. x1 is the number of moles of first gas, x2 is the number of moles of second gas, like this you can write. Or instead of number of moles, if mole fraction is given, then you can write mole fraction also. Similarly, instead of mole fraction, if mass percentage is given, then also you can substitute. Similarly, instead of just mass of the gas is given, then also you can substitute. Are you able to understand? So this is one more equation to calculate molecular mass of mixture of gases. Understood, Dhamma? Molecular mass of 1 mole of a gas. Mass ki, total mass ki, molecular mass ki confuse avvaddandi. Okay? So, what is called M1 here? M1, M2, what are them? They are molar masses. Or you can call them as molecular masses, or you can call them as molecular weight, or you can call them as mass of 1 mole of a gas. Okay? So there are many methods in which we indicate mass of 1 mole of a gas. Understood, no? Come on. Make a note up to here. Okay, ma? So next concept which we are studying is Dalton's law of partial pressures. See, ma, here, consider this is a container in which 3 gases are present. 3, 4, any number of gases can be, more than 1 gas is present. Clear, no, ma? Then what happens is total pressure which is experienced by this container. Okay, ma? Actually, why container will experience pressure, ma? See, ma, here, inside this container, there will be gas molecules or gas atoms, no? Molecules will be present. And at normal temperature or any temperature except at minus 273. Except at minus 273, at any temperature. Even at minus 272 also, these molecules, they will be moving. Or if it is a solid, the molecules of a solid will be in vibration. Okay, ma? So these gas molecules, they will be moving in random directions, no? So in the process of moving, they go and strike with the surface of the container. Okay, ma? So molecules continuously, they will be undergoing collisions with the surface of the container. Collision means it is giving some force, no? Force per unit area is called pressure. So on the container, who will give pressure actually? These molecules only, they are giving pressure because of continuous collisions. Surface of container, though, eppudu collide avutune untayi avi. And force applied per unit area is nothing but pressure. Okay, ma? So therefore, total pressure exerted by all the gases will be how much? That is the sum of pressure exerted by first gas plus pressure exerted by second gas plus pressure exerted by third gas. This is understandable only, no? Huh? The rocket science emundi ikkada. Total pressure is nothing but pressure exerted by first gas plus second gas plus third gas. That's it. Understood, ma? And what is this PT? PT is nothing but total pressure. Okay? And what is this PA, PB, PC? They are called as partial pressures. Partial pressures. Partial pressures means what, ma? Pressure exerted by each gas is called partial pressure. Are you able to understand? So total pressure is equals to the sum of individual pressures. That is called as Dalton's law of partial pressures. Very simple concept, you know. So write down the statement of this one. So the total pressure exerted by gas is the sum of, or you can say is the algebraic sum of. Algebraic, why we are writing? Because pressure is a scalar quantity, no, ma? It doesn't have any direction. So vector sum we are not taking, we are taking algebraic sum. Okay? Algebraic sum of partial pressures exerted by individual gases. Okay, ma? This is called as Dalton's law of partial pressures. Okay? So listen now. See, here one point I can understand is that if first, listen very carefully. If first gas is having 10 molecules, second gas is molecules I am writing. Second gas is having 30 molecules in the same container. Okay? And the third gas is containing of 100 molecules of gas number 3. then which gas will exert more pressure on the container? Huh? Definitely this gas will exert more pressure. No? Why? More number of molecules are there. More number of molecules, they will be striking with the walls of the container. No? Are you able to understand? No? And this gas will exert lesser pressure when compared to third gas. This will exert still lesser pressure. So therefore, can I say that pressure is directly proportional to number of molecules of a gas? Definitely I can say no. Okay. So this is the most simplified model of understanding partial pressures. Clear? So pressure is directly proportional to number of molecules. If number of molecules increases, pressure also increases. So, and number of molecules depends on moles of gas only. No? First gas is 10 moles, second gas is 30 moles, third gas is 100 moles. Definitely third gas will exert more number of pressure. So therefore what I can write, again I can write pressure is directly proportional to number of moles of a gas also. Okay. Therefore I can write, if I want to compare these two gases or three gases, I can write P1 by P2 or PA divided by PB. Pressure exerted by first gas divided by pressure exerted by second gas. It means it is ratio of pressures, no? And this must be equal to the ratio of number of moles of a gas also. Okay. This is a very, very, very important relation by which we can do many kinds of problems. Okay. So the ratio of pressures is always equal to the ratio of number of moles of that particular gas. Okay. So statement wise, how can I write? The ratio of pressures of a gas of two gases is exactly equal to the ratio of moles of those gases. Understood, Nama? So what is the ratio of pressures? Same will be the ratio of number of moles also. Understood, no? Okay, ma? Similarly, we can write down. So instead of like this, I can write equation in another form also. I can write. Okay, ma? I can also write pressure of a gas divided by total pressure is equals to number of moles of that gas divided by total number of moles. I can write like this also. No? Understood, Nama? Instead of comparing only two gases, I can take a fraction with total pressure also. And similarly, I can take moles in terms of total number of moles also. Here I have compared two gases, no? There what I have done, I have compared the pressure of one gas with total pressure of the gas. Similarly, I have compared number of moles of one gas with total moles of a gas. So I can write like this also. Understood, Nama? So therefore, this is one method of writing. Or same relation I can write like this also. This relation, how I can write, PA is equals to PT multiplied by NA divided by NT. I can write like this also. Okay. Now what is meant by PA? Partial pressure. PA means pressure of only one gas, no? That is called partial pressure. Okay. So partial pressure is equal to, now PT, total pressure. NA by NT. NA, moles of one gas. NT, total moles. Then it is called mole fraction, no? Fraction of moles is called mole fraction. Clear, no? So partial pressure is equals to mole fraction multiplied by total pressure. I can write like this also. So this is also a very famous relation. Okay. So partial pressure of any gas is equals to mole fraction of that gas multiplied by total pressure of the gas. Understood, number? So these are the different methods of understanding Dalton's law of partial pressures. Clear? Understood, number? Very easy. Okay, ma? Now see. So a container has 1 mole of nitrogen gas and 1 mole of hydrogen gas at 300 Kelvin. So what is the volume of the container? Volume of the container is 10 liter. Okay. Then calculate the total pressure of on the container before reaction and after reaction. Understood, Nama? So first of all, we will study before reaction. It means before these two gases they react, what will be the pressure on the container. Understood, Nama? So therefore, how can I write? See, ma, here N1 is equal to N2 is equal to 1, no? Number of moles of nitrogen, number of moles of hydrogen, they are same. So therefore, already we studied that P1 by P2 is equals to N1 by N2, no, ma? So this is 1. Therefore, P1 is equals to 1 into P2. So therefore, pressures are also same. It means that pressure exerted by which gas? Nitrogen gas on the container, and pressure exerted by hydrogen gas on the container, both are same. Both gases will exert same amount of pressure. But that's not what he is asking. No, he is asking total pressure. So I can use ideal gas equation. So PV is equals to nRT. Are you able to understand, ma? So pressure I can write P1 plus P2, partial pressures, no, ma? And total volume of the gas is always same. Okay. Number of moles are how much? 1 plus 1, 2. 2 moles of gas is present. Or you can write one thing. You can write Na plus Nb multiplied by R into T. You can write the equation like this. So this is the equation for one gas. Same equation I am modifying for a mixture of gases. Is it clear? Okay, ma? Therefore, so total pressure is nothing but P1 plus P2 is equal to Pt, no, ma? Therefore, what I can write? Total pressure multiplied by volume. What is the volume of the container? 10 liter. Clear, no, ma? So this is equals to Na plus Nb. How many number of moles? 1 plus 1? 2 moles multiplied by R multiplied by what is the temperature? Temperature is how much? Where is the temperature? 300 Kelvin. So it is given in Kelvin only, no? You need not convert into another scale because Kelvin is the SI unit of measuring pressure. So therefore, do the calculation, 1 0 and another 0 get cancelled. So total pressure is equals to 30-60 R. So 60 R is the pressure. Understood, no? That's it. So one more question is there, no? After reaction. After reaction. So let us see. So after reaction, that is after hydrogen and nitrogen, they will get reaction with each other. So hydrogen plus nitrogen, they give rise to NH3, no, ma? But equation, is it balanced? No. So how to balance this one? 2 N2 is there, I will place a 2 here. Clear, no, ma? But how much is there here? 3 is there, but here 2 is there. So what can I do? I can write like this. 3 H2. Okay, ma? So 3 H2 plus N2, they give rise to 2 NH3. Are you able to understand? So if reaction should happen completely, satisfied, no? 3 2s are 6, 3 2s are 6. Okay, ma? If reaction should happen completely, it means every molecule of hydrogen and every molecule of nitrogen, if they should react with each other, then 3 moles of hydrogen should be present and 1 mole of nitrogen should be present. Understood, no? So here I will write after reaction means in this condition also I will write 2 cases, ma. How can I write 2 cases? So here only 1 mole nitrogen and 1 mole hydrogen is given, no, ma? So therefore, how much part of nitrogen will react and how much part of hydrogen will react, that we have to see here. Okay? I will do one thing. I will divide everything by 3, ma. Okay? So 2 NH3 will form, no? Instead of this equation, I will do one thing. I will write H2 plus N2. N2 should be how much? 1 by 3. And they gives rise to NH3. Clear, no, ma? So therefore, how many moles will form here? Balance this equation. So hydrogen only 1 mole is there, no, ma? But nitrogen will react. How much part of nitrogen will react? Only 1 by 3rd of nitrogen will react, no, according to this one. So here I have written 1 by 3. Now how can I balance this one? How can I balance this one? 3 by 2 can I write? Or 2 by 3 now? Now is it balanced, ma? 3 by 2 n is there. Here only, no. I have to write it as 2 by 3. Now it is satisfied, no? Now the equation is balanced. Are you able to understand, ma? So therefore, 1 mole of hydrogen will react with how many moles of nitrogen? Only 1 by 3 moles of nitrogen will get reacted with each other. Then how many moles of NH3 will form? 2 by 3 moles of NH3 will form. Are you able to understand? Then remaining how many moles of nitrogen is left with? Only 2 by 3 moles of nitrogen is left. Okay. So you calculate the pressure of 2 by 3 moles of NH3 and 2 by 3 moles of nitrogen. Then add both of them. That will be the total pressure after reaction. Have you understood anything? So that's the reaction which I have written, to form NH3, 3 moles of hydrogen and 1 mole of nitrogen should react. So therefore, but how much hydrogen is given? Only 1 mole of hydrogen is given. So 1 mole of hydrogen can react with how many moles of nitrogen? Here it is only 1 by 3rd, no? So I am writing 1 by 3. 1 mole of hydrogen can react only with 1 by 3rd of nitrogen. Are you able to understand? Then again, if you balance this one, then I have to write 2 by 3 of NH3. Understood, no? 2 by 3 of NH3 means so only this much amount moles of NH3 is formed. So hydrogen is completely utilized, no? 1 mole of hydrogen is given and 1 mole is completely utilized. How many moles of nitrogen is present? 1 by 3 is utilized. Remaining nitrogen is not reacted, no? What is the remaining nitrogen? 2 by 3rd of nitrogen is present. So therefore you have to calculate pressure because of how many gases? 2 gases. So 2 by 3 moles of NH3 and 2 by 3 moles of nitrogen. So calculate total pressure. That will be the pressure after the reaction. Are you able to understand? This is how we have to do it. Come on, try to do. Understood, Nama? So now do the calculation. So therefore, finally how many moles of gases are left with, ma? So 2 by 3 moles of NH3 is left and 1 by 3rd mole of nitrogen is utilized. What is the remaining nitrogen present? 2 by 3 moles of nitrogen is present in the gas. Is present in the cylinder. Understood, Nama? Therefore, do the calculation. Again, same concept. So P1 plus P2 is equals to N1 plus N2 into RT. That's all, no? So what is the pressure of first gas? 2 by 3. Pressure of second gas? 2 by 3. Total pressure I want to calculate. Now I will make it as PT. Number of moles of first gas? 2 by 3. Number of moles of second gas also? 2 by 3. Multiplied by R into temperature is 300. Clear, Nama? So therefore, what is the total pressure? 4 by 3 multiplied by R into 300. So, volume I forgot, no? Sorry. Volume is how much, ma? Volume is 10. So multiplied by 10. So therefore, PT is equal to how much, ma? So 10 and this one get cancelled. So 3 1s are 3 10s are. So how much, ma? 40 R. That is my answer. Okay. So final pressure in the container is how much? It is only 40 R. Is it clear? So this I am multiplying with V. I forgot to multiply with V here. అర్థమైంది కదా ఎలా చేస్తాం? వెరీ సింపుల్. మళ్ళీ క్వశ్చన్ వినండి. Sima. So 4 grams of hydrogen and 32 grams of SO2 are present in a gaseous mixture at NTP, normal temperature and pressure. Normal temperature and pressure means what? 20 degrees Celsius and 1 atm pressure, 1 atmospheric pressure. Okay? And STP means what? 0 degrees Celsius, 1 atmospheric pressure. Then the question is, what is the partial pressure of hydrogen when compared to the partial pressure of sulfur dioxide? So that is when compared to the pressure of SO2, hydrogen is giving how much amount of pressure? Comparison I want to calculate. Okay. So anybody, can you say how can I do this calculation? So what he is asking actually, pressure of H2 divided by pressure of SO2. This is what he is asking. No? If I can know this ratio, then I can say what is the partial pressure when compared to hydrogen. When compared to SO2. This is comparison with SO2 only, no? So can you say how can I do this calculation? ఎవరిని డివైడ్ చేయాలి? Sima. Already we have studied a relation, Nama. The ratio of pressures is equal to ratio of number of moles. Already we have done this calculation. No? This is the relation which we are supposed to use here. Okay. Number of moles, how can I calculate? Number of moles is total mass divided by molecular mass only, no? So first of all, I will calculate for hydrogen, then I will calculate for sulfur dioxide. So for hydrogen, what is the mass given? 4 grams. So 4 divided by, what is the molecular mass of hydrogen? 2. So 2 moles of hydrogen is present in the container. That's all, no? What about SO2? So 32 grams of SO2 is given. What is the molecular mass of SO2? 64. So this is also 2 moles. Both are 2 moles only, na? 0.5. Sorry. So 32 by 64 is half mole. 0.5 moles of SO2 is present in this container. Okay, now substitute here. So the number of moles of hydrogen is how many, ma? 2. Number of moles of SO2 is 1 by 2, so 4. That's all, no? Clear? Therefore, pressure of hydrogen, partial pressure of hydrogen is 4 times when compared to partial pressure of sulfur dioxide. That's all. This is the method of calculation. Understood, no? That's very easy. Okay. And this molecular masses, you should remember, ma, for at least 50, 1 to 50 atomic numbers, you have to remember their molecular masses also. So, in periodic table, you have to by heart all the elements group wise, atomic numbers at least up to 50, atomic masses at least up to 35 to 40. Then that is enough. Okay, ma? Now see. So question is that equal weights of ethane, C2H6, and hydrogen are mixed in an empty container at 25 degrees Celsius. Ma. Clear? Weights are equal. Weights means in the sense masses are equal. Okay, ma? If mass is equal, weight is also equal only because we are present on the same planet, no? So no problem. So the fraction of total pressure exerted by hydrogen is, so what he is asking, ma? So pressure exerted by hydrogen divided by total pressure. This is what he is asking. No? Pressure exerted by total pressure is called fractional pressure. Okay, ma? So therefore, this relation I can also write it as number of moles of hydrogen divided by total number of moles also I can write, no? Because already we have studied what is the fraction of pressure. Same will be the fraction of number of moles also. Okay, ma? Number of moles fraction ent untundo, pressure fraction kuda ante untundi, because pressure depends on number of molecules. The number of molecules is decided by number of moles of a gas. Okay. Now do the calculation. So number of moles, how can I calculate? Mass is given, nama. So therefore weight is given. Mass divided by molecular weight. Weight divided by molecular weight is called number of moles. This is the formula, no? Small m divided by capital M, or you can write weight divided by molecular weight. Anything, both are same. In physics we use weight and mass to be synonyms, ma. Okay? Because chemistry people, they don't know difference between mass and weight, no? So they will use mass and weight to be synonyms only. Are you able to understand? So mass and weight both are same in the case of chemistry. Okay? So therefore, now do the calculation. So partial pressure of hydrogen divided by total pressure is equals to, so number of moles of hydrogen. Masses are same, no? So weight is same. W divided by, what is the molecular weight of hydrogen? Molecular of hydrogen is 2 divided by, so molecular weight of total gas I want, so number of moles of total gas I want, no, ma? So weight divided by 2 plus weight divided by, and C2H6. C2H6 molecular weight, so C 24 plus 6, 30. That's all. Clear, no? So weight will get cancelled. So therefore what I am left with, 1 by 2 divided by LCM, if I take 30, then it is 15 plus 1. Okay, ma? So 1 by 2 multiplied by 30 divided by 16. So 2 1s are 2 15s are, so it is 15 divided by 16. That is my answer. 15 is to 16. Understood, no? That's it.